Yeah, let's try to learn another technique today. That's a two-pointer technique. So from the two-pointer technique, we'll use we'll see some examples for that. So it's like in the last video we saw two sum problem using the hashing technique. So we'll see the similar problem using the two-pointer technique. So let's see, that's code here, and we'll try to understand. Okay, so here is a code for this. Let's try to understand the problem. We'll see the code and also jump to the explanation portion of that. So this is the two sum 2 problem where input array is sorted. So if you see this array is a sorted 2 7 11 15, and in this case we have given the target 9, and we want to find this index for this target 9. So we know that 2 7 adding this 2 7 becomes 9, so index is 0 1. If it is like here it asks for one base index, so in that case we can say like it's a first index, second index, so that's output 1 and 2. So that's a problem, and how we are using the two pointer technique. So in this code we'll see there are two pointers, I and j, and an I and j, and this we fix the first pointer in the beginning and the other pointer at the end, so that these are the two pointers, and we are checking I less than j. So that's a loop where we are checking I less than j. So how this works, we'll just understand this logic, and again we come back to this coding portion. So let's copy this example first and try to understand how the two pointer technique works. So it's a 217. Okay, so what we do, and we know that target is 9, so what we do here, we fix our pointer like left pointer at beginning, so that I can say I equal to 0, and j I can fix at the end, so end is 0 1 2 3, so that's a length is 4 minus 1, so that's a right pointer. And then we check whether this sum of this the left pointer and the right pointer is equal to our target or not. So we'll 2 plus 15, we'll add this and check whether it's equal to target 9. So if it is equal to target 9, then return that. If it is not equal, then in that case we'll check another condition, like if 2 plus 15 less than 9. So 17 is not less than 9, but in case if it is less than 9, then we usually increment I. But in this case 2 plus 9 less than, it's not. So like let's say it's a if condition, and if it is true, then it's I plus plus, else that means else it's a j minus minus. So let's try to understand our scenario. So our scenario is 2 plus 15 equal to 9, no. 2 plus 15 less than 9, it's not less than 9. Then in that case we'll move the right pointer to left side. So what does that mean? When we move this right pointer to left side, then the new sum will be less. Definitely it's going to be less, because this is this is in ascending order, and the 2 15 17, and if it is we're moving this side, then that add the addition that will be less, and this side again less. So that's why we checked here 2 plus 15 less than 9. No, it is not less than 9. So the number is this, this number is still bigger than our target. So if it is bigger than target, then we need the lesser number. So we'll move this right pointer to left side. So then in the next case, when we move our pointer to 11, then in that case our left pointer is at 2. So we'll calculate the new sum. We'll see the 2 plus 11. So is the 2 plus 11 equal to target 9? No, it's not 9. Then 2 plus, we'll check 2 plus 11 less than target. No, it's also not less than target. Then it is not less than target, it's still bigger than 9. So if it is bigger than 9, so in that case again we'll move the right pointer to left side. that is j minus minus. So in this case, now check 2 plus 7 equal to 9. So yeah, so it is 9. 2 7 plus is 9, so it's a return the result. And if you do not find the result, return the empty. Let's see another scenario from this example. So 2 3, yeah, so see this example 2 3 4, and try to understand how it's working. 2 3 4, and the target is 6. Target is 6. So we'll fix the first pointer here and the end pointer at the end. So in that case, 2 plus 4, yeah, so this is we find the target here itself. 2 plus 4 targets, we find the target and return the result. So that's what it's the logic. Let's see the code here again, once again. So our first pointer is at 0, last pointer, or we say the right pointer at the end, and we are saying okay, I less than j, because we know that when we move the left pointer to right side and the right pointer to left side, and sometime the I will less than j. So in that case, will just come out. So we'll see, okay, this number I and j, left and right pointer equal to target, return the result. So this is I is the index and j is the index, but this is a 1 base index, that's why I'm adding 1. So I plus 1, j plus 1. Else if with the num I and num j less than target, then I plus plus, else j minus minus. And then, so this is the golang code. In the similar way, I tried this in Java also. We can see the Java code also here. So Java code. So I submitted this and it's running, so that's fine. So in the Java code also, it's the same. Left pointer 0, right pointer here, and I have one loop here, I less than j, and checking with equal to target, return the indexes. And if it is less than, it's a number I and j less than target, then I plus plus or j minus minus, else j minus minus. So that is all about this 2-pointer technique. We'll see few other examples based on this hashing or 2-pointer technique in the next video. So that's all for today. Thank you.